So there's a little hint on how to pronounce my name, if you were wondering. And I've got a bit of a cold, so excuse me for that. But luckily we're remote, so it's fine. I'm Wietze. I work on EO data engineering and yeah, I've been working on GDAL, been involved with GeoZarr. I found an issue from 2023 when I was at a company called Space Intelligence, and we were basically duplicating data. So that's sort of the origin of my involvement in GeoZarr. It's still kind of motivation nowadays. Um, so this talk, I know probably most of you work with like X-ray, Python, and this is a bit more C++ related or in depth, but it won't be too technical. It's more about how to get Zarr data on a map, and so you can do visual inspection, etc. Um, so my initial problem with this was that there's basically data duplication happening. So you want to do awesome machine learning, but also do quality control, quality checks on the data, and for that you need visual inspection. So what happens in practice is that then data gets duplicated, and it's kind of hideous to want that. And at sort of a small company scale, that's fine in a way. But if you're talking about Sentinel archives, that's petabytes, and uh, just feels kind of stupid. But I think it's probably bound to happen anyway. But that's fine. This sort of paves the way towards having one format to do both analysis and visualization. Uh, so what is GeoZarr? Um, like some of you may know, so it's three modular conventions. It's still work in progress. It's heading towards OGC standardization. So spatial tells you the geotransform, so where do pixels live on Earth. And then there's geoproj, that gives you the CRS, like an EPSG code or WK2 string. And then there's multi-scales, which gives you overview pyramids. And in Zarr, these get stored as sibling arrays. So when you zoom out, the reader picks a smaller array instead of downsampling the full image. So all these need to be found by the software. So they live in one Zarr.json and one HTTP request should give a tool of any tool like QGIS everything to render from that JSON. These three conventions are modular, so these are picked for GeoZarr, but they can also be plugged anywhere else. Okay, now I want to do a little demo. So bear with me. I do have a backup in case this doesn't work. Let me find the other, my QGIS. I'll just show you a bit about QGIS. Can you guys see my QGIS?
I actually see part of your slide, like the index to your slides.
Okay, wait.
Now I see on half your screen the slides, and half your screen looks kind of blank. Okay,
Okay,
I briefly saw QGIS.
wait, let me try again. I'll stop and I take it the slides were showing earlier.
Yeah, your slides look great.
Okay, perfect. Uh,
Yep, QGIS.
Perfect. Okay. So here we have QGIS. This is a quite recent one. It was complaining about me updating it, but basically I built this plugin. It's nothing too fancy. It's like I think it's like 500 lines of Python maybe. You can find it through the plugin browser. Uh, just search for GeoZarr and you get this, and you can install it, and then you get this fun icon here. But you
Sorry,
can.
just to let you know, we don't see the pop-ups. We only see the main interface.
Okay.
Just in case that helps
Okay.
for
Yeah, you
as
might
you're
need to share
presenting.
the whole screen.
Thanks. That does help. So let me just go through the browser then, because that's probably also the most easy way to interact with this. So QGIS browser panel has this stack option since I don't know when. It didn't exist always, but in here I've connected with this stack API, which lives at, and you can't see my pop-ups, I suppose. So, well, I'll put the link to this. Basically, it's this URL and the space is a slash. So you connect to that, and then you see different catalogs, one for Sentinel-2 with different scenes. I'll just grab a recent one. And then thanks to this plugin, there's a new option called Load GeoZarr, which opens a pop-up, which you can't see, but I'll I'll just take the default, click OK, and then it will load this item, and you get it on the screen. So it works. It's pretty fast. Like it can always be faster, I guess. I've been trying hard to make it as fast as we can. Like it's like you see the chunks and the shards being accessed if you zoom and pan around. Uh, I did some effort in maybe making like an outline of the shards. I didn't get to finalize that. Maybe I'll share that afterwards. But you get the idea. So you basically get interactive Zarr in QGIS. Hey, move back to the slides. What you just saw working pretty smoothly. A month ago, that was horribly slow. So there was like 81 HTTP requests per shard going one by one sequentially. And now it's fetching a shard in one go. And there's still some latency with North America to Germany, but it was pretty good, I think. This is the result of quite some PRs into GDAL, which is sort of the foundational layer that's used there to load the data. That's what QGIS uses. So you go down to a head, like four requests only. So you get a head for the resource metadata, a get for the Zarr JSON, and then another get for the shard index. Um, and then you also do another get to get all chunks in one multi-range request. A little more detail. On the left, what GDAL did a month ago. So every open started with probes for Zarr v2. which for afford. So GDAL was outdated. That's and or wasn't yeah didn't follow Zarr v3 yet, and now it does. So I think there are still a few gaps, but like the majority is pretty much solved. So uh, yeah, there were also things like the coordinate arrays, like the X and Y. They were re-downloaded for every band, which was quite expensive. Then get for each chunk sequentially, and now it's nice and clean. It's still it's Zarr, so it's not just like as compared to Coq, it's not one file. So it's yeah, maybe it's not the drag and drop you were dreaming of, but it's pretty fast. Um, and you do need a config for GDAL, which is GDAL number threads, and it like set that to all CPUs. The plugin does that for you. But if you're working on this with other code, then be aware of that. So here's some benchmarks. So these are local benchmarks. So data is already on the disk, and this is warm cache. I don't think we've really formalized the benchmark framework for this yet. So this, in a way, it's a bit premature. Work in progress, but was keen to get sort of a comparison. And it also helps sort of where, like when you're profiling the problem of speeding this up, it helps to find like which one to focus on. So um, for the overview read, that means zoomed out, rendering the entire tile at reduced resolution, like what you saw in the demo when it zoomed out. Um, a cog does that faster compared to Zarr. Both feel pretty instant. Um, the full resolution zoom, uh, yeah. Sorry. So the parallel row is about uh, multi-core scaling. That 1.1 means cog barely gets faster when you add cores, going from 1 to 8 threads. Cog overview reads only speed up, yeah, just 1.1, whereas Zarr speeds up quite significantly. Zarr also compresses data better in terms of volume. So there was a post from Element 84 that also drove this motivation a bit on that. Essentially, we're talking about the same thing. It's just sort of it's the same values stored on disk, but the data is uh, accessed differently. So it's sort of the tooling. So why is there a gap? So, oh wait. So the gap was quite significant because of Zarr v2, and now that's pretty much closed for the majority. There's still some parts left. Uh, I was looking for it. It was hard. At some like the first ones were quite simple, or like it was sort of the low-hanging fruit. But now it's getting harder. I see. Um, so yeah, I I checked for data type conversion, memory copying. Um, so I think they're both pretty fast. Cog is still faster. I think we can close the gap, but the data structure is just different, and Zarr is more versatile. And I think at some point it's worth paying the price. Um, so maybe a bit more about the context of this. So the standard isn't official yet. It's getting there. So folks at EOPF Explorer working on this. That also launched. There's a website for it, and I think there's an event for it next week, if I am not mistaken. So there's already a lot of production data out there in sharded Zarr v3 that already adopt these GeoZarr conventions. But until like a few weeks ago, you couldn't really load that nicely in QGIS. Uh, there's T-Tiler that reads directly from Zarr using GDAL as well. And there are probably some benefits from these efforts as well that will trickle down. So on the desktop, you now have the data in QGIS at interactive speed, no like web interface for it. So you can also access the same Zarr store through X-ray, Zarr, and Dask for analysis in one format. You store it once and render anywhere. So yeah, GeoZarr is a community where it's a monthly meeting. Max is involved in that, Chuck is involved in that, and many others as well. So feel free to join. Just finished before this call. The conventions that are used there are reaching maturity. They're being checked with the OGC. And yeah, I think now the bottleneck is, well, there's probably still some optimization to be done in the code, but it's now also about formalization and getting this through working group votes, etc. So if you don't really bother about that, you can also just try it. And here's how to do that. You can get this plugin installed in QGIS as detailed here. And then as shown, you can go to the browser panel, stack, new connection, and load some Sentinel data. There's a caveat here that this is relying on GDAL from master, which is supposed to land in GDAL 313. That's supposed planned to be released mid this year. So you can either build GDAL from master and run it against that, or wait for that to land. And yeah, also if you don't have QGIS, you could go to that website, and there's some well, web map visualizations as well. So you get T-Tiler to show the data for you. So Zarr isn't just for analysis anymore. One format archive to analyze, to do an analysis on your screen. Huge thanks to Evan Ruel. And made a bunch of PRs. He reviewed them, so I was very happy that it took a few iterations to get sort of in sync on how we communicate it. And I mean, Pangeo is built on open science, open source, open data. If you want to try it out yourself, anyone can profile it, find a bottleneck, and submit a fix. No short feelings. Thank you very much.